For the past 40 years, astronomers have known that something about the cosmos doesn't add up.
What is the exact process astronomers use to date a star, where they can tell if it's 1 year old, 10,000 years old, 100,000 years old, million years old, or billion years old? I would like to know. Can somebody tell me? Stay cool. This is a Thor News presentation. Thor News presents... You're right, sir.
Slow your rotation, stellar fool.
Hey, y'all. I'm talking about baby stars. That's right, I'm at the Daily Galaxy, talking about a monster infant star discovered in our Milky Way. It's a baby, and it's 30 times the size of our sun. How does that work? I have no idea. But let's read this article and find out, shall we? Astronomers have identified a young star, located almost 11,000 light years away. I guess the Milky Way's big. How big is the Milky Way? It's gotta be at least 12,000 light years across, I guess. Which could help us understand how the most massive stars in the universe are formed. This young star, already more than 30 times the mass of our sun, is still in the process of gathering material from its parent molecular cloud, and may be even more massive when it finally reaches adulthood. Well, how do you know when a star is like a baby, and then a child, and then a teenage star, and then an adult star, and then a middle-aged star, and then an elderly star? You gotta have some type of classification system. I'm sure the IAU had a very heated debate on this and came up with specific definitions, maybe? The researchers, led by a team at the University of Cambridge, have identified a key stage in the birth of a very massive star and found that these stars form in a similar way to much smaller stars like our sun. Crazy. That's weird. Like, did you guys know that tall people form the exact same way that short people do? Yeah, it starts out with the birds and the bees, and it ends with tall people and short people. But, conceived and born about the same way. From a rotating disk of gas and dust, the exact same way tall people and short people are formed. Or was that Pinocchio? The results will be presented this week at the Star Formation 2016 conference at the University of Exeter, and are reported in the monthly notices of the Royal Astronomical Society. You see, an average star like our sun is formed over a few million years, whereas massive stars are formed orders of magnitude faster, around 100,000 years. And Dr. John Lilly from Cambridge's Institute of Astronomy and the study's lead author said, these massive stars also burn through their fuel much more quickly, so they have shorter overall lifespans, making them harder to catch when they are infants. The protostar that Lilly and his colleagues identified resides in an infrared dark cloud, a very cold and dense region of space, which makes for an ideal stellar nursery. However, this rich star-forming region is difficult to observe using conventional telescopes, since the young stars are surrounded by a thick, opaque cloud of gas and dust. But by using the sub-millimeter array in Hawaii and Carl G. Jansky Very Large Array in New Mexico, both of which use relatively long wavelengths of light to observe the sky, the researchers were able to see through the cloud and into the stellar nursery itself. That makes them sound like peeping toms. Like, if it ain't your baby, ain't no reason you should be looking at the baby. I guess unless it's a star and you're an astronomer. It's early. I've been punching myself in the face all day. And they can see through all the junk in between now and between here and 11,000 light years away. Pretty hard to believe. By measuring the amount of radiation emitted by cold dust near the star, and by using unique fingerprints of various different molecules in the gas, the researchers were able to determine the presence of a Keplerian disk, one which rotates more quickly at its center than at its edge. And I'd like to know again, what is the exact process astronomers use to date a star, where they can tell if it's 1 year old, 10,000 years old, 100,000 years old, million years old, or billion years old? I would like to know. Can somebody tell me? I guess I have to Google it. This type of rotation is also seen in the solar system. The inner planets rotate around the sun more quickly than the outer planets, says Lilly. It's exciting to find such a disk around a massive young star, because it suggests that massive stars form in a similar way to low-mass stars like our sun. Okay, but I still am unclear how you guys know this one's a baby one. I mean, you're just like, it's a baby. Take my word. I'm like, okay, maybe not. No, that doesn't sound cool. I have a question. Who can I ask? How come none of these reporters ever ask questions? The initial phases of this work were part of an undergraduate summer research project. Oh, it's undergrad students. At the University of St. Andrews, funded by the Royal Astronomical Society, the undergraduate carrying out the work, Puneet Narazi, said, my project involved an initial exploration of the observations and writing a piece of software to weigh the central star. I'm very grateful to Roz for providing me with funding for the summer project. I'd encourage anyone interested in academic research to try one. Yeah, sure, great idea. From these observations, the team measured the mass of the protostar to be over 30 times the mass of the sun, with their mass scale, I guess. In addition, the disk surrounding the young star was also calculated to be relatively massive. Wow, I calculated that to be relatively massive. Between 2 and 3 times the mass of our sun. Dr. Duncan Forgan, also from St. Andrews, and the lead author of a companion paper said, our theoretical calculations suggest that the disk could in fact be hiding even more mass under layers of gas and dust. The disk may even be so massive that it can break up under its own gravity, forming a series of less massive companion protostars. Wait, what? So the disk is going to break into 5 disk pieces and then create 5 protostars. Fascinating. Can I see photographs of this process? Pretty please. The next step for the researchers will be to observe the region with the Atacama Large Millimeter Array, located in Chile. This powerful instrument will allow any potential companions to be seen and allow researchers to learn more about this intriguing young heavyweight in our galaxy. Rho Cassiopeia, shown at the top of the page, belongs to an unusual class of stars, a yellow hypergiant, of which only 7 have been found in the Milky Way, despite being located over some 10,000 light years away. The star is visible to the naked eye. Wow. Because it is over 500,000 times more luminous than the sun. With surface temperatures between 3,500 and 7,000 K, yellow hypergiants appear to be stars that are at a very evolved stage of their life and may be close to exploding as supernovae. Well, the story is way more boring than I thought it would be. For that, I apologize. And we don't have a name of the star. We just get artistic rendering. I can't get a name of the star so I can look up photographs on my own. I feel cheated. I hope you do not feel the same. Aw, shucks. Peace out. God bless everyone.